Thank you very much. What a wonderful building this is, huh? What a wonderful facility. So I'm very excited to be here this afternoon to tell you about two things that I'm quite passionate about. One is microbit, and the second related thing is something we call PXT. The slides are coming up, I presume. Sweet. So, but before I get into microbit and PXT, I want to give you a little bit of background for these two things. And that's really what, in a nutshell, it's computer science education, at schools, right? Teaching our kids computer science, coding, and computational thinking. And very much related to that is a strong belief I have, and I share with many others I know, that physical computing, having real tangible, tactile hardware devices, is a really engaging way of learning to program. So I'm going to start with, I wonder if I can, is this working as well? Does this one work? Okay. Which is, got it. Is that good? Fantastic. So I've got a bunch of factoids here. You have to be a little bit careful about these statistics. But pretty much any way you look at it, and I'm sorry that they're not all fitting on the screen, but we need more computer scientists. We need more people with digital skills. So in the bottom right-hand corner here, there's a statistic from the UK where I come from. We need 745,000 more employees with digital skills. Someone has calculated over the next year, right? In the States, this is that's digital skills. That's not just computer scientists. That's a more generic type of skills. But in the bottom here, in the States, apparently there are over 500,000 jobs currently open for people with computer science skills. But you're only producing in the States. We're only producing 50,000 graduates with the right qualifications every year. So it's going to take 10 years, right, to fill all those spots. And of course, it's actually been predicted in the next 10 years, there's going to be demand for more like 1.5 million people with these skills. And at the top there, right, so 90% of parents in the US want to have the opportunity for their children to learn computing and coding at school. But at the moment, only 1 in 4 schools in the US offer programming classes. So the good news is that around the world, governments and ministries of education are sort of waking up to this fact. They're realizing that this is happening. So back in 2012 in the UK, the government commissioned a report, and the report was published, and it said that every child should basically have the opportunity to learn computing as a foundational academic subject. So if you think about it, we teach everyone physics when they go to school, and we don't expect them all to become physicists, right? But you need physics in a lot of different careers you might choose to follow. But in fact, you need an understanding of physics really to get through life. And if you think about today, well, computing science, understanding of computing and coding and computational thinking is, I would argue, equally important. So in the UK, from 2014 onwards, the government mandated the teaching of computer science across the board, right? From kindergarten through to year 12, you have to be taught computer science. And other countries around the world are following suit. So this is great in that we realize we need to teach our kids computing, but there's a couple of things we'd like to do in addition. First of all, we want to engage those students. We want them to get really excited to learn. And also, we want to engage a diverse range of students. We don't just want to appeal to a certain type, right? So traditionally, computer science, there's a particular characteristic of person. Like I'm a bit of a geek, and when I was at school, I loved that kind of thing. But it doesn't appeal to everyone. We want to engage a diverse audience. And the other thing we want to do is give teachers the tools and the materials they need to help them, because all around the world, if the ministries of education are saying, hey, we need to teach all our kids computing, the teachers don't necessarily have the experience to do that, so we want to give them some help. So if I return back to the UK, when this report was published and the government started making these changes, the BBC, the British Broadcasting Corporation, got to thinking about what was something they could do to help. So the BBC is obviously associated with broadcast media, with TV and radio and web content. But actually, the BBC has a long tradition in learning support. And there's a division called BBC Learning, and they make a lot of materials to support teachers and students. And that's really where the idea of the BBC microbit came about. The BBC thought, well, there's all this research which shows that physical computing is a way of getting kids engaged. Why don't we build a small physical computing device? We'll get together a partnership of organizations from industry and elsewhere, and we'll design and build this thing which we call microbit. And I think, has anyone actually heard of microbit before this? Oh, that's fantastic. So to give you a little bit of a flavor, for those who don't know what microbit is, I'm going to show a short video which we might need to adjust the sound on.
The microbit is a pocket-sized computer that lets you get creative with digital technology. You can code, customize, and control your microbit from anywhere. Light up the LED display to create something simple in minutes, or even communicate between microbits. Or get really creative with microbit's more advanced features, like its buttons, motion detector, compass, and sensors. You could create a guitar that changes the volume the more you shake it. Or a flick football game that powers a microbit scoreboard. And you can connect it to other devices, sensors, and everyday objects. So you could water your thirsty plants, or use Bluetooth to take photos with your phone, and control your music player. And you can customize the microbit in any way you can imagine. It's really anything you want it to be.
I think it's a bit like a robot.
It's quite different to any other technology I've sort of used before.
You just have fun with it.
I can control my tablet. You can make games, you can take pictures.
Kind of something that senses movement, and you can just place it in your pocket and make whatever you want.
We'll describe it as a future.
So here's a picture of the microbit. On the front, as you probably saw in the video, there's a number of LEDs, 25 LEDs. So this is essentially the sort of lowest resolution, cheapest screen that we could think of. They're just red LEDs, they're not even multicolor. There are two buttons for interaction, and there's this edge connector you can see along the bottom. So the idea here is that there are some larger connection points that you can use crocodile clips with or put plugs into to get some basic functionality, extensibility. But there's also a number of other pins, and if you use an edge connector, you can plug it into a device to expand the hardware, as it were. And on the flip side, you can see it has an accelerometer, it's got a digital compass, it has temperature sensing built into one of the processors, it actually has light sensing using the LEDs, using some of the LEDs on the other side. On the top left, there's a BLE, a Bluetooth antenna, so it actually supports BLE. Up in the top right is a little a power connector, so you can connect it to a couple of AAA batteries and use it standalone. But while you're with a PC, you can also supply power over the micro USB connector at the top, and that's how you program the device. So when it comes to programming the device, this is a screenshot, a little bit, okay, we've lost a little bit of it, but this is a screenshot of the UI that myself and some of my colleagues in Microsoft developed as part of one of our contributions to the project. So we have three elements here. So on the very left-hand side, there's actually a runtime simulator. This is all running in this is a web app. This is running in a browser. So you don't need to install any software on your computer to have this experience, which is really important in schools in particular, because it means that teachers can try it out and they don't have to go through a lot of hoops with their IT departments. And on the left-hand side, we have a simulator, which means as you edit code in real time, you're getting a little simulation. You can see a graphic of the microbit up there in the top left, and that's actually, the LEDs will be flashing on the screen as they would on the real device. In the middle, we have like a coding panel where you can code either in in Scratch, well, Google Blockly, right? A Scratch-like blocks programming language. Or in the latest version of our website, which is what I'm showing here, you can take a JavaScript view. So the idea is we're providing a progression from blocks to JavaScript. And on the right-hand side, we have the sort of documentation panel. So what I think I want to do, though, is give you a demo. So I've just had the 5-minute warning. So let me switch this off maybe here. Let's see if we can make this work. So I'm actually going to quit out of PowerPoint, if that's all right. So this is our programming environment. This is one of the devices. So the first thing to do, I'm going to plug the device in over using a micro USB cable. And actually what happens when it plugs in is it appears as a mass storage device. So there are no drivers to install. I've just got this disk, which is called microbit. And if I go back to my programming environment here, you can see there's a little bit of code running here already, right? So I've got a forever loop that's showing 2 patterns of LEDs. So I'm showing this smiley face of LEDs, and then I'm showing this blank screen. So these are just, for those of you who are not familiar with Blockly, right? These are just blocks, and you can snap them together to create your code. And on the left-hand side here, you see I mentioned that there's a live simulation. So there's my flashing smiley face. And what I could do, for example, is I could say, I only want, rather than having that happening all the time, I only want to do that when button A is pressed. So it goes away in the background and starts running that new code, so there's nothing happening. But if I was to press button A, now my smiley face is flashing. So this is all a very virtual experience so far, and the whole point of physical computing is you can get really hands-on and tactile. So what I'm going to do is click over here. I'm going to click on the UI here. I'm going to click download. And so what happens now is I get a little advice dialog, but I've got this file which has been downloaded into the web browser, and I can drag that and I can drop that onto my microbit. And as I do that, it actually reflashes the device. So the file is copying, Windows is copying the file over. It works on any operating system, right? The file's being copied over, and as it does so, the device is being flashed. So it's done. It should be running now. So if I see if I can make this work, actually. So I'm just running a camera here from this laptop. So the device has got power coming into the back there. There's nothing happening on the front. But if I press button A, the power of the demo, yes! Smiley face, thank you. I have done it a few times, but it always is a bit of a relief when it works. So I think probably in the interest of time, I just wanted to show you a couple of other things. So I probably won't program the device again, but I'll show you a couple of other things you can do. So for example, we've got an input section here. So these are different blocks to do with different types of input, because again, we're trying to make interactive devices, make it a really tangible experience. So I could actually, let me get rid of this stuff, right? So what I'm going to do here is I've got, in my LED section, I've got this thing here which plots a bar graph. It's not really a bar graph in my mind, but basically it lights up more LEDs if the number's bigger and fewer if the number is smaller. And the thing that I'm interested in plotting is acceleration. I know that ranges from, well, I think it's 0 to 123. So I can say, let's come up here, and I can just say, just repeatedly plot a bar graph based on the accelerometer, right? So this is based on the orientation of the device. So if I had this running on here, then as I tilt the device, the number of LEDs would change. But what's happened in the programming environment is because it's seen I'm using this acceleration facility, as it were, now when I mouse over, it's tilting. So in the simulator, I can simulate different orientations, and you can see as I tilt it more LEDs light up and fewer LEDs light up. And another kind of cool feature over here is we have this documentation panel, But the way the documentation, I've done documentation for hardware projects in the past, and you kind of like, you're writing some instruction, you have to take a screen grab and you paste it in, and then you explain what the user has to do next, and then you get another screen grab. But what we're trying to do here is have more dynamic documentation. So here's a picture of what you might need to do, that first example I gave you, to make a smiley face flash. But you can actually run it here, sort of in the documentation, because it's all just JavaScript. And the other thing I nearly forgot to show you is I mentioned this JavaScript view. So you're learning to code using Blockly, but if you want to know what that looks like as a text-based language, you can just click JavaScript, and you see it there, and you can even edit it, right? So if I was to delete that and say, no, actually the range goes from 0 to 123, when I go back to the blocks view, you will see that it has changed here. So the idea is we can go backwards and forwards between these two views. Okay, so let me just finish up. I think I have one more slide. Let me see if I can make this. Yeah. So I just wanted to give an update on the status of the project. So we did this as a partnership that was led by the BBC. So the BBC were inspired us, right? They had this audacious goal to design and build 1 million of these devices, and we did that. We got sponsorship from a number of companies. So some of the hardware companies provided the chips for free, for example, and Microsoft helped with the programming software. As you see here, so it was actually around Easter time that we delivered these devices to schools to go to the children. But in the meantime, what's happened is the microbit project, as it were, is almost it's transitioned from a BBC thing to a new not-for-profit organisation called the Microbit Foundation. So the devices are actually already available to buy in the UK, and it's the foundation who's working with manufacturing partners to make them available across Europe initially, and then early next year, as I understand the timetable, to North America and other places. And then something that we all care about is like the openness of the design. So the programming environment I showed you has been open source for like over a year now. The runtime firmware, which runs on the device, sort of like almost like a mini operating system, which was developed by Lancaster University, one of the partners, has been open source for many months now. And the hardware design is due to be, I'm told, to be open source actually this month, later this month. So that's it. Thank you.